All right, let's talk about applying point slope form. So from the last video, we had that point slope form is given by y minus y1 equals m times x minus x1, where m is the slope, and x1 comma y1 is a particular point on the line. Okay, we are going to go through a full example together, but before we do that, let's look at a couple of things. So let's say I gave you this equation, y minus 3 equals 2/3 times x plus 1. Okay, so this is in point slope form, so you should be able to look at this and identify the slope and also the particular point. Okay, so what I see is here we have 2/3, so m is the slope, so m is equal to 2/3. Okay, actually let me just write slope is equal to 2/3. Okay, but what is the particular point that's on the line? Okay, here's where some errors get made. Okay, so let's look at this. What's the particular point that's on the line? Notice that these two equations are almost the same, other than if you look here, there's a minus here and a minus here. But over here, down in what we're given, we have a minus and a plus. Okay, so what we really technically would want to do is get it totally into the proper form. So let's rewrite this as y minus 3 equals 2/3 times x minus a minus 1, which is an equivalent statement. And now we are exactly in point slope form, and we can read out the coordinates of the particular point. Okay, here's our x1 and here's our y1. Okay, so actually let me even do this, put parentheses over here. Okay, so our point, our particular point, let's write it out. Particular point is -1, 3. Right? It's an x y ordered pair. Okay, let's do one. So let's say I gave you another equation. Y plus 5 equals 7/3 times let's say x minus 2. For this one, you should be looking over here. This is the slope, so let's write slope equals 7/3. If we wanted to get it exactly into slope intercept form, once again, we want to have negatives in both positions. So we could write this as y minus 5 equals 7/3 times x minus 2. Now we have it exactly in the proper form. So it looks like here's our x1 and here's our y1. So our particular point is 2, -5. In reality, I don't even do this step over here. What I do, I kind of skip this. I don't really do this myself, and I don't do this. What I do is I look at the equation right here and look what number would make both sides equal to 0. Okay, because if both sides of this equation are equal to 0, that means the equation is true. Okay, so I could see I would substitute in a 2 over here to make this side 0, and I would do a -5 on the left-hand side to make it 0. So I know that the point on the line is 2, -5, okay, which matches what we did earlier. Backing up to the previous example, I would just look at both sides of the equation. What is going to make both sides equal to 0? Okay, if I plug a 3 into here, it's going to be 0. And if I plug a -1 on the right-hand side, it'll be 0. So I know the point is 3, -1. Okay, I think I got that backwards, right? The coordinates. That's actually the x is -1, so -1, 3. Okay, so that matches what we got earlier. Okay, so for me, that's an easier way to think of it. Okay, you could choose whatever makes sense for you. Yeah, I think we'll kind of stop here. We'll save the example for another video.